Imagine you are standing on the bank of a river just before a flood is about to arrive. You know water will rush in from upstream and you are certain it has to exit downstream. But exactly how do we tell a computer to mimic that process? That is where boundary and initial conditions come in. Welcome back to Hydrology Hub. Today we will reveal the story of how rivers come alive inside HEC-RAS simulation by setting up boundary and initial conditions the right. Think of the HEC-RAS as a theater play. The river geometry is the stage, the flow data is the script, and the boundary conditions they are opening and closing doors of the stage. We tell the model where water enters, where it leaves, and what the water is doing at time zero, the moment the curtain raises. Without this, the play can't even begin. So let's talk about why boundary conditions are needed. In unsteady flow, we solve for discharge Q and stage Z at each node. For a reach of river, there are n computational nodes which bounds n minus 1 finite difference cells. From these cells, 2n minus 2 finite difference equations can be developed. Because there are 2n unknowns, delta q and delta z for each node, that means two additional equations are needed. These equations are provided by the boundary conditions for each reach, which for subcritical flow are required at the upstream and downstream ends. That means finite difference gives 2n minus 2 equations, but there are 2n unknowns. Now here the boundary conditions provide the missing equations. That's why boundary conditions ensure a unique and stable solution. Your upstream boundary. We usually describe it with a flow hydrograph, the story of discharge over time. Now, at the river's exit, it is not about how much water leaves, but about the water level of control conditions downstream. That is why we use a stage hydrograph or a rating curve or sometimes just normal depth when we have no better data. The golden rule is upstream we consider flow and downstream stage. Inside the HEC-RAS, the unsteady flow data editor is like the control room of a dam. Here you enter every single boundary condition, external and internal. It is where you say, this is how water enters, this is how water leaves, and this is what happens inside the system, like lateral inflows, dam operations, or groundwater exchange. The editor is literally your dashboard to control the river simulation. HEC-RAS makes life easier by automatically listing all external boundaries. You just click on a location and assign the right condition. Not sure what is allowed? No worries. HEC-RAS grays out the irrelevant options so you don't accidentally assign the wrong one. And yes, you can even add your own internal boundaries to simulate tributaries, rainfall, or gates. Flow hydrograph is like a diary of the river. It tells you exactly how much water enters over time. In HEC-RAS, you can import it straight from the HEC-RAS DSS file or write it manually into a table. If you go manual, first set a time interval, say hourly, then decide, do I want this hydrograph to always begin with my simulation? That means the simulation time, or do I want it to match real world clock time like historic flood, that is the fixed start time. At the downstream end, the story changes. Here we don't care how much water enters. We care about the water level control. Think of a tidal river. The ocean tells the water how high its water will be. That is why downstream options include stage hydrograph like tide data, rating curve, a stage discharge relationship, or normal depth when we are guessing with Manning's equation. That's why a flow hydrograph downstream is not considered. That is like trying to control how water leaves a bucket, not natural and usually unstable. It is like deciding whether your story is fictional or based on a true event. A stage hydrograph lets you set water level over time. Perfect if you have gauge data. A rating curve is like a deal between river and its gauge. For every stage, I'll give you a discharge. But beware, rivers don't always keep this promise during the floods. Place rating curves far enough downstream to avoid errors creeping back into your reach. Next is the normal depth. It's like the model's best guess. Using Manning's law, it estimates the water surface, quick and easy, but just an approximation. Of course, rivers have surprises. Tributaries join in, rainfall add extra flow, groundwater seeps in. That is where internal boundaries come in. You can add lateral inflows at a specific point, uniform inflows spread along a reach, or groundwater interflow, which is modeled using Darcy's law. Darcy's law tells that flow through soil depends on hydraulic gradient, conductivity, and area. It is the invisible exchange between river and aquifer. HEC-RAS even lets you create special situations, gate opening over time, navigation dam operations, or internal stage or flow boundaries that act like a temporary dam. But be careful. If your internal stage suddenly ends and the model switches back to computed values, you can get a shock in the results. So, here is the story in nutshell. Upstream, we have to consider the flow hydrograph. Downstream, stage or rating curve or normal depth. Inside the system, lateral inflows, groundwater and gates, and initial conditions, the stage set before the first act begins. The boundary and initial conditions are the script that tells you river model how to behave. Without them, HEC-RAS is just an empty stage. Thank you for watching Hydrology Hub. If you enjoyed this journey through the river's story, don't forget to like, share, and subscribe for more hydrology storylines. Thank you very much.